Welcome to Cinemeric Live, easy to understand application technology. Our video series explains Cinemeric topics in a simple, practice-oriented way and will take up just a few minutes of your time. Today, we look at effective multiple clamping for milling. These topics encompass the basic principles of multiple clamping in the application, and of course, how this is all implemented in the Cinemeric Operate. Naturally, a practical section is once again incorporated for our machining center with the Cinemeric 828D. One prerequisite for productivity during manufacturing is optimum utilization of the machine space, that is, the machine table. Here you see a negative example of how it shouldn't be. In contrast, three-way clamping, an optimum or at least improved utilization of the machine space in order to achieve increased productivity within the scope of optimal manufacturing is immediately evident. The animation demonstrates the conventional type of programming and processing. We have three identical components, and each component involves three different processing operations. This means that a tool change must take place 3 times for each component, as processing is always carried out subsequently or additionally from one part to the next. The conventional type of processing is shown in the upper section of the schematic representation. 3 identical workpieces, each with 3 machining processes, where each machining process is simply adapted repeatedly for the other part. For 3 workpieces with 3 machining processes respectively, this then equates to a total of 9 tool changes. This is ineffective. As shown in the lower section, the most desirable variant, that is the effective variant, is 3 identical workpieces and 3 different machining processes. However, only 3 tool changes. This reduces non-productive times for the machine. One way in which this effective variant can be implemented is output from a CAD/CAM system, and the output in the G code will then yield these program sequences. It is therefore easy to imagine that any modification outside of the CAD/CAM environment is extremely difficult. The function for implementation of this effective manufacturing variant in Cinemeric Operate is the multiple clamping function. Once again, we see here the conventional variant on the top right and the large representation on the left with the sequence of machining processes following optimization of the tool change using the multiple clamping function. Each diameter is representative for a different processing sequence. And you can see that the small hole is drilled first, then the medium-sized hole, and then the large hole. A tool change is then only performed after the machining sequence has been completed for each component. Implementation of this effective manufacturing variant in Cinemeric Operate is as follows. A complete generated program in ShopMill, compact program output. The multiple clamping function can be found in the Program Manager menu option. Following activation of the multiple clamping function, another window opens in which the parameters are entered. A detailed description of precise functioning is provided in the practical section. Essentially, there are 2 types of multiple clamping available. One is the linear multiple clamping and the other the rotation symmetric multiple clamping, also known as reversible clamps. In this case, the machine must feature an additional rotary axis for each reversible clamping device, thus guaranteeing extremely compact clamping of the workpieces, which can also be effectively manufactured in large batch sizes. However, it should be noted in particular here that we require an additional customized clamp cycle for this rotary axis when using reversible clamps, called cust clamp. This ensures continued cycles at the right time for the rotary axis. Here a brief look at the cust clamp cycle in this user-defined clamping cycle. Each individually set and programmed number of degrees can be clearly seen here at a glance: 180, 270, 90 degrees. This is simply the trigger for the axis to continue rotating around the corresponding number of degrees. However, this should not be confused with the rotation and swivel cycle of the Sinomeric operate with the cycle 800. That has no relevance here. And most importantly, whoever uses the cust clamp should ensure that the machine has also been supplied and commissioned with at least one functional rotary axis. Before we commence with the practical side, another particular highlight of the multiple clamping function. As well as the effective manufacturing of identical components, the same naturally also applies for entirely different components, which can also be arbitrarily combined with one another in exactly the same way and manufactured effectively with the multiple clamping software function. Here we have our setups with linear clampings on the right, a purely linear clamping in which 3 workpieces are placed next to each other, ready for machining in this order. On the left we have what's known as a 4th rotational axis, which rotates around the x-axis. It combines the linear clamping with rotational symmetrical clamping, making it possible to effectively machine even more workpieces in an extremely limited space. Let's start with a purely linear clamping without the software functionality for multi-clamping optimization. Later, we'll repeat the process with the software functionality, which will help us see the differences with regard to machining, shorter machining times and so on, very clearly. Here is the program for this component. In it, the individual operations are processed one by one, and the 2 other programs are then called for the 2nd or 3rd clamping. What does all this look like with the multi-clamping function? Here we have just one program. Let's take a look. It comprises a pure sequence of processing steps as they would be executed for a single workpiece. But since we want to manufacture 3 workpieces, we'll select the multiple clamping function in the Program Manager. The first window shows how many clampings we have: 3. The second field contains information on the first work offset where the program is to start, followed by the next 2, in our example G562, with the second at 563 and the third automatically at 564. In this field, we enter a name for the program we are creating for copying. Enter OK. Next, we select the program that we want to copy. In this case, it's this program. And there's another advantage. We can say on all clampings, which means that 3 identical programs are copied. Of course, we can also integrate completely different programs into the optimization. In our case, we select on all clampings and you can see the individual 0 points where the 3 programs are going to be placed. Next, we say OK, and the program calculates and optimizes the tool change. And here we have the newly created program. As you can see from the length, it has about tripled in size. And this is what it looks like. We basically have the same three sequences with the individual information placed in between the processing steps to optimize the program for the sequence. But first, let's start processing without the multi-clamping software to see what that looks like in the real world. Select the program, and off we go. Let's now switch from purely linear processing with multi-clamping to a combination of linear and rotation clamping. The processing sequence is the same as for just linear clamping, only with considerably more workpieces and one other special feature worth mentioning. Because we are dealing here with positioning through rotation, we must always bring the workpieces back to the processing position. All this happens with the so-called cust clamp, a user-defined cycle that is used in this clamping situation to continue rotating the fourth axis at a specific time. It basically serves as a trigger to implement the rotation. As with purely linear clamping, you mark the program that you want to copy using the multiple clamping function. It's exactly the same procedure. And what does this all look like in practice? Select, close doors, and press Start. As you could see, the manufacturing time was significantly shorter. And there were fewer idle times too, thanks to the reduced number of tool changes. Plus, we also have much less programming work in addition to reliable and convenient copying of processing programs. One thing to bear in mind: this only works in ShopMill, not in G-code programming. That's all from us today on the topic of multi-clamping. Thanks for watching, and see you next time.
Siemens. Ingenuity for life.